Let's do one final example of consumer and producer surpluses. Example 5.4.5. A commodity has demand and supply function. I have a D of X. Notice that it's a small d. Some teachers like to use that, so I want to make sure that you realize it's the same thing. That's the demand function. That's the supply function. All right, so we're told to find the equilibrium for this market. So I'm going to set both of them equal. So D of X equals S of X. That means 2,000 over x plus 1 equals 5 over x plus 1. If I send the x plus 1 to one side and the 5 to the other side, I'm going to get 2,000 divided by 5 is 400 equals x plus 1 squared. Now I can solve for x plus 1. I'm going to get plus or minus 20. And so either x is 20 minus 1, which is 19, or x is minus 20 minus 1, which is minus 21. This one makes no sense. I cannot have a negative number of product being sold. And so the only equilibrium we have is at 19. So 19 units. And for those 19 units, the price would be, I could put it into either. If I put it into D, I'll get 2,000 divided by 20. I'm going to get 100. And so my equilibrium point is 19,100. All right, I want to find the consumer surplus at the equilibrium price. So at $100, consumer surplus is 0 to x0. D of x, the d is above, so that's top, minus p0 dx. So I'm going to get 0 to 19. D of x is 2,000 over x plus 1. P0 is 100 dx. All right, so to integrate this, I would use a substitution. I would substitute for x plus 1 since that's inside my denominator. So I'm going to get the integral. I'm going to plug in the bounds, and so I'll get 1 to 20, 2,000 over u minus 100 dx, du. And so I'm getting 2,000 log of u minus 100u, and I'm going to plug in 1 and 20. All right, so I computed it. I'm going to round it because these are real life objects. In fact, I expect you to round it to the nearest cent. And so the consumers are saving $4,091.46 when paying $100 instead of their maximum price. All right, producer surplus. I'm asked in C to find the producer surplus at the equilibrium point. So producer surplus or formula is similar but slightly different. It involves a supply function instead of the demand, and P0 and the supply are flipped. All right, so 0 to 19, P0 is still 100. S of x is 5x plus 1. This one is easier to integrate, so I will not do it. It's just a polynomial. You should get, well, actually, it's equal in this case. It's equal to $902.50. And so the producers are, well, they're not saving, right? They're getting extra. extra are earning $902.50 extra when they are selling at $100 instead of their bottom price, instead of the minimum that they were willing to take. All right, so they get a bit of extra because they all come together and decide that they should sell at 100, regardless of the fact that Tony would sell for 50, that Bridget would sell for 75. They all decide to sell at 100, and so Bridget would get an extra 25 for each cell phone they sell, and Tony would get an extra 50. All right, perfect. That's it for producer and consumer surplus. In the next section, I'm going to do one extra example. I'm going to find the area of a disk. The only reason I'm doing that example is because it leads to an integral that we don't quite know how to integrate. And that's going to be what we learned in the next chapter, in chapter 6. So I want to show you how natural this type of integral is, and then we'll spend chapter 6 learning how to do it.